Tenha dado boost, uma energia. I hope coffee was a booster to continue with this very interesting morning. So this morning we had a talk on feedstock and services from the bioeconomy, and now we're going to talk about new products around us. So as a keynote speaker to this session, I would like to introduce you Michael Carras. Michael is founder and managing director of the Nova Institute, and he will start by making a broad overview on renewable carbon, so that after that we will talk about materials replacing fossil fuel-based ones. Okay, Michael. Hello, nice seeing you.
You need suitable language and communication to be successful on the market. And last not least, policy, economy and policy. Policy is in many regions in Europe, but also in US and Asia, more impacting than ever our business. And so we have to understand in detail what policy will do the next years and when to interact with policy. We're working for brands, for chemical industry, for automotive, for international bodies. Our main target group is the chemical industry because we think they are crucial in the transformation to switch away from fossil carbon. And so we work with the smallest and biggest one in the world to make this transition happen. With our new webpage, and what is exciting for you are our market reports. Only a very quick view, so on anything you can imagine, we have market reports on bio-based polymers, Ludo-based polymers, bio-naphtha, different organic acids, and most of our publications are free of charge. You can just download it. And this is also true for the graphics I will show today. You don't need to make screenshots or smartphone pictures from it. You can just download them from our webpage in high resolution. Important services, our daily newsletter. We have 220,000 readers monthly. Here you find everything on bio-based, CO2-based, and chemical recycling. Okay, coming to the concept of renewable carbon. The first point is it's not CO2 that is at the core of the climate problem. Also, it seems so. But the additional fossil carbon that we take out of the ground and which gets released in the atmosphere as CO2 or other emissions. If we can prevent this flow from carbon from the ground, then we can really stop climate change. And this is an important message because CO2 itself, it can be run in cycles. But the additional CO2 from the ground, this is a problem. This shows on the next slide here. This is calculating in different reports how much from the fossil carbon we are still allowed to extract from the soil to stay in the climate, in the temperature target, 1.5 degree. And so it's about 80 to 90% of the crude oil, natural gas and coal we have to leave in the ground. Otherwise, there is no way to stay in the temperature range we need as humans to survive on this planet. And so it's a clear message, we have to find other carbon sources. And I will, before I go in detail, I think there are 6 challenges we have to cover. The climate mitigation star we have developed. The first, we start on the left top and going then around the cycle. Renewable energy from solar, wind and others. This is crucial. We have to invest huge amount in renewable energy. Then the next one is decarbonization of energy and transport via electrification and green hydrogen. And number 3, if decarbonization is not possible, we need renewable fuels containing carbon. So solar, wind, electricity, for example, is not enough for aviation. So there are some fields left. We need carbon also in energy. Next point, land use. Agriculture has a strong carbon footprint today, and this has to be changed in the future. Circular economy, improving circularity and efficiency. And last but not least, in my topic today, renewable carbon from biomass, CO2 and recycling for chemicals and derived materials. And I have summed up the whole concept in one slide. The first point is 72% of the greenhouse gas emissions are directly related to additional fossil carbon from the ground. 72%. That's really a lot. If you ask where the other 28 are coming from, they're coming from agriculture and forestry, from deforestation, from meat, milk and cheese production. This also has to be tackled, but the main focus is additional fossil carbon from the ground. And another threat for humans, on our planet, is biodiversity loss. This can be also very well tackled with climate, if you tackle climate change, because climate change is one of the most important drivers of biodiversity loss. Decarbonization with renewable energies is a good strategy for the energy sector, but no issue for chemicals materials because they are based on carbon, like humans also. There's a lasting and even increasing need for carbon, for chemicals and materials. And the only way to handle this is to phase out the fossil carbon and looking for other carbon sources. So the key challenge is to replace the demand for fossil carbon by alternative carbon sources. So the equivalent to decarbonization in the energy sector is a transition to renewable carbon in the chemical material industries. And we have 3 options. Biomass, where this conference is mainly about, direct CO2 utilization and recycling. And we call the 3 together under one umbrella renewable carbon. And we define it as renewable carbon entails all carbon sources that avoid or substitute the use of any additional fossil carbon from the geosphere. Renewable carbon can come from the atmosphere, biosphere or technosphere, but not from the geosphere. Renewable carbon circulates between biosphere, atmosphere and technosphere, creating a carbon circular economy. And this is where the vision looks like. On the left-hand side is the energy sector. Renewable energy, solar, wind and hydro can cover the total demand in the future. We have hydrogen as an energy carrier, as a storage. And then you see hydrogen also the bridge to the material world. CO2 plus hydrogen is methanol, methane, formic acid, naphtha. You see the biomass here, you see recycling. And so we have the material world is completely based on renewable carbon and the energy world completely on solar, wind and hydro. And there's only a few left over for carbon-based fuels. You see this one arrow going back to energy. This is our aviation fuels, kerosene. There is no solution in the near future to substitute the carbon in kerosene, hydrogen, or electricity, at least for long distance flights. When we look into the chemical material sector, and this is, for me, still a very impressive picture, because you see, if you look into the total demand of the material sector for embedded carbon, so the carbon in the molecules, then it's already 50% bio-based today. This is really impressive. You see the big share of wood construction and furniture, pulp and paper, and textiles. This is mainly cotton here. And then in the chemical part, we have also 10% biomass. And this is exactly 50% bio, 50% fossil. So this is really impressive that we are already so far. But not in the chemical industry itself. And when we're looking only to chemical industry and derived materials, then we see still 85% is based on fossil carbon, crude oil, natural gas, and coal. Only 10% on bio and 5% on recycling. And so the challenge is, in an increasing carbon demand world, to replace this 85% by bio, CO2, or recycling. You can also have a deeper dive and see that in different sectors, the share of fossil is very different. I will not go here in the details because only 50 minutes today, but we have a lot of more detailed data. We have data on carbon flows worldwide, carbon flows in Europe, and what are fossil, bio, and CO2 carbon flows. All this data are available. This here is a scenario for 2050, where we don't use any additional fossil carbon on the ground for chemicals and derived materials. The main part is recycling, 55%, with including chemical recycling for sure. And it could be, if you only look into polymers, it could even be higher. But here we have also detergents and solvents, which are not so easy to recycle if they went to the environment. So recycling is number one, 25% CO2 based, mainly from cheap solar energy. We can make commodities like naphtha or methanol. And then we see bio-based 20%. This is a strong increase from today, so huge increase. The whole demand goes up from 450 to 1,000, just because of population growth, bigger middle class, higher income. And biomass cannot substitute or cannot deliver this 1 billion ton of carbon because of biodiversity restrictions, biodiversity loss. So this mixture from bio, CO2, and recycling can replace the fossil system entirely. And this is our message. Then we look what it means for plastics, for example. The plastic in the future will be 70% recycled, mechanical and chemical. And then the additional carbon, because the cycle is never closed, the cycle has losses in production, in collection, and recycling. Then another 30% are fed with biomass and CO2. And again, if you will calculate the numbers, it's bio-based, seems to be small here, but in fact, it's much bigger than today. So we have to expand the bio-based polymers by times 10 to deliver this input here. Yeah, I think because I have only 2 minutes, I have not so much time to go in all the details here. Bio-based polymers is developing well. We have growth rates between 5 and 15% for the next years. We see a lot of investment in bio-based polymers. That's a very good development. The areas that bio-based polymers taking are still very, very low, is 0.006% only. And you see on the right-hand side also that there are more and more also using bioproducts like glycerol or non-edible plant oil. But if you have a deeper look, it's also not a problem to use food crops if you do it the right way. And then finally, in my last 2 minutes, I want to show you the initiative, Renewable Carbon Initiative. It was founded in September 2020. We have our first annual meeting next week. And the initiative want to speed up the transition to renewable carbon, to bio, CO2, and recycling. And we have meanwhile 30 members, and you'll see here the large enterprises, the biggest chemical companies here, BASF and DuPont. We have end consumer companies like Unilever and Reckitt, We have companies Lansing, cellulose fibers, UPM, the biggest biorefinery in Europe. So we have many different companies here. This join one vision to replace fossil carbon. And Unilever, for example, has pronounced that in 2030 they not accept any fossil carbon in their detergent products. This is a high challenge, pressure on the value chain, but you see the brands doing here very good policy to change the dependence on fossil carbon. We have also well-known SMEs on board. Avantium, very well known in the bio-based world for the PEF polymer. Lanzatec is a leading company in utilization of CO2. We have today on the market already CO2 made from polypropylene, polyethylene made from CO2. We have startups here, BioEconomy expert and WW. WW is making lactic acid and PLA from food waste. And if you look to the partners of the initiative, WWF is on board, and the others are specific on their sectors, on textiles, on PHA, on CO2 utilization, and the European Circular Bioeconomy Fund for investment in the sector. Yeah, and my last two slides when I'm ready. So this is a renewable material tree. So we can keep on going our lovely products of today, but disconnected from the fossil carbon made from bio-CO2 and recycling. And if you want to learn more about it, we have a conference on cellulose fibers, one on CO2 utilization, and then the biggest event we ever did on May, where we're bringing all solutions at one place, 3 days on bio-CO2 and recycling, best solutions for a sustainable world. Many thanks for your attention. If there would be some questions, I'm very happy to answer it.
Thank you, Michael. Thank you very much. I'm sure there's lots of questions because carbon circular economy sounds intriguing. I hope that the next panel will be able to take this up and tell us a bit more. But before we move on, I would like to show you one of the bioproducts of the Amazon region, a real hit. It's a fruit that is the base of smoothies, juices, desserts, and sweets. And it's also used for pharmaceutical and nutritional purposes worldwide. I am talking about the acai that we've been hearing about since we arrived here. Acai, I would not know if it has any translation in English, but that's been used for centuries and consumed by the Amazon people. And now its production has set a prosperous business for a large number of communities. Let's watch a quick documentary about a man whose main concern is to increase his production in a sustainable way. Please, can we have the video?
Na verdade, a gente tem essas áreas de terra de herança, vem passando em gerações. Eu já sou a 4ª geração que está trabalhando com isso. Meu bisavô conseguiu em 1914 as terras, tudo começou, na verdade, ele começou a trabalhar com cacau e depois foi surgindo as palmeiras do açaí e aí começou uma procura pelo fruto. O meu avô, ele tirava o palmito da palmeira do açaí porque, na verdade, financeiramente era fraco, o fruto. Mas agora, como está na alta, está um valor bom, o fruto, a gente prefere trabalhar com uma palmeira do açaí para o fruto, não para o palmito. Porque no momento que você planta a muda do açaí, o pezinho do açaí, ela leva 3 anos para começar a produzir o fruto. Mas quando ela começa a produzir o fruto, eu tenho aqui na minha área aqui palmeiras com 12 ou 13 anos que eu estou colhendo fruto todo esse tempo dela. Todo ano tem fruto para colher. E aí a vantagem é que anualmente eu consigo colher de uma palmeira 14 quilos de fruto. Então, enquanto a gente faz esse bosqueamento, esse manejo, a gente acaba fazendo corte de matos, folhas da própria palmeira que cai, a gente corta menores, e aí isso vai se destruindo e virando orgânico para as palmeiras, adubo orgânico. Vou mostrar aqui, ó, esse é o material que nós usamos para fazer a peconha, que nós chamamos de bocó, que cai da palmeira do açaí quando amadurece a folha, e a gente tira as lâminas para fazer a peconha, que aí é usado para colocar no pé, que é para facilitar a subida e a descida na palmeira do açaí com fruto. E esse aí é com material próprio mesmo da natureza, é tradição daqui da região, usar esse material. E aí eu acho que uns 30 anos atrás, mais ou menos 25, 30 anos atrás, começou a exportação de Belém para outros estados. E aí foi que as pessoas começaram a trabalhar mais em cima do produto, que é o açaí, hoje. Eu estou aqui há 45 anos, né? E acho que ainda vou continuar uns quantos anos aí, se Deus quiser.
Very nice. If those of you who were at the theater 2 nights ago and watched the show Árvores que se Tocam, os dançarinos, os artistas tinham estes ramos na mão e iam...
The players had those branches in their hands, the leaves of the acai tree.
Show 2 nights ago at the local theater were waving those branches. Okay, so having said that, I would like to call the next panel on a bio-based alternative for materials. I will start by asking Bibiana Rubini to the floor again, one lady, the only one on stage. Thank you, Bibiana. Very good having you here. And then we have on screen Janne Poranen, Roberto Werneck, Nelleke van der Poel, Alper Kidzitas. So welcome everybody. Thank you for being here. And I will ask my colleague and friend Ludo Diels, Research Manager, Sustainable Chemistry Flemish Institute for Technological Research. He's also the Vice Chair of the Public-Private Partnership SPIRE. Ludo, welcome here. Thanks everybody for being with us. And now you're in charge. Thank you.
Thank you.
Thanks a lot, Teresa. What's happening? Is it okay now? Yeah. Okay, thanks a lot, Teresa, for the introduction, and we really look forward to a very nice panel discussion. Of course, it's a little bit a pity that we are with so many people just remote, and we will not be able to drink this evening some acai smoothie or whatever. So we will miss this, but we look forward to a next opportunity. So I'm very happy with the panel, and especially also some words of thanks to Bibiana, who is representing our panel on stage. And so it's very nice to have at least one person in person on stage. In the first session this morning, we learned from Sven Walter about the forests and the forest-based products that drive the bioeconomy. Konstantin Zoner made clear that 1 trillion of trees can be added to our planet with a very high impact on CO2 capture, so really a huge amount of possibilities. But he also put some question marks to it, because of course it is not because we have the potential that this will be done. So there's a lot of huge investment to be done to realize this, but there is really a very high opportunity to plant a lot of extra trees on our planet and to capture in that way a lot of carbon. The subsequent panel showed how ecological initiatives can contribute to the economic benefit for local communities. And I think the movie that we just saw on the acai is also a very nice example of how local communities can benefit from this tropical forest bioeconomy based systems. But now in this panel, we would like to go a step further and look at the global climate mitigation scale by drilling into the need of carbon-based materials. And this is in line with what was presented by Michael Karras a few minutes ago. Michael Karras presented us the Renewable Carbon initiative, where recycling of fossil carbon is of course also a circular approach, but the two others can contribute really to capture and to become a sink for carbon. And in that way, of course, it is extremely important to have further discussion on that. Maybe we will focus more on the biomass carbon compared to the CO2 carbon in this panel, because of course we are on a biomass conference, but of course we will open the discussion for the two. But we are also supported by another manifest, which was made by Hasso van Progrel, but unfortunately he is not with us. Normally he had to be the second speaker, but he made it very clear. Hasso is the director of the Bioplastics Association in Europe, and he made very clear that bio-based plastics can be made in all kinds of directions. We can add this to our materials. Based on this knowledge, let us come now to this next step in this panel. I don't know what is the reason of this noise problem. Yesterday it was already mentioned.
It's the first hiccup we have this morning. There's a small technical problem in your sound, so it's in looping. Okay, so we're trying to fix it.
It doesn't seem so small, but we will see. Okay. Yesterday in the CEO panel, there was a lot of discussion about what is a side, the feedstock that is treated by the process industry, for instance, the pulp and paper industry and all these kind of related companies that are really becoming big refineries, and they are producing for instance, pulp that is a material or a bio-based material, and then it is used by the manufacturing industry to make finally a product that is bought by the consumers. And the consumers, and it was yesterday mentioned several times, the brand owners that sell these products to the consumers are really looking forward now to have materials that have a lower footprint, materials that have a higher content of recycling, recycled material, or materials with a lower CO2 footprint, in a way that they can offer more sustainable products to their consumers. And the panel we have in front of us is really today combining these two. So process industry converting the feedstock into the materials, and then the manufacturing industry converting the materials into real products. And in that way, we really look forward to move forward with it. So our first person I would like to present is Bibiana Rubini. She is on stage, so I give her the favor to be first as a speaker. Bibiana is Suzano's RD&I Executive Manager with a focus on pulp and biorefinery since January 2019. She started 15 years ago at Aracruz Cellulose, so cellulose fibers. She moved then to Fibria, and after the merging with Suzano, she took the management of RD&I of the biorefinery as well. She is a Master in Science in Chemical Engineering, graduated at the Universidade Federal de Paraná, and she has several specializations in pulp and paper and an MBA in project management. She is currently taking an executive leadership training at the Harvard Business School. I will bring the different bios in function of the questions that we discussed. So let me first start with a first example of this process industry. Bibiana, very welcome. And your company started as a pulp and paper company and is now moving to a bio-based materials company. What is the driver for this transition, and how are you doing this? What is really making that, if I can say, a classical pulp and paper company is moving into this direction? And do you think that bio-based products can also contribute to higher performance of the materials compared to the fossil-based materials? Viviana, you have the floor.
Thank you, Ludo. Good morning, everybody. Good morning, fellow panelists. It's a pleasure to be here with you today, talking about the subject that biomaterials, so dear to myself and to our work at Suzano. As Ludo said, Suzano is a pulp and paper company, and it's doing that for the past 97 years. So almost 100 years producing renewable, bio-based materials. We are currently the biggest market pulp producers. We produce eucalyptus bleached pulp for the market, 11 million tons. And what we realized, and I think it wasn't just Suzano that realized, is that the forest can do so much more than just pulp producing. The forest sector can actually take a lead position in this transition to biomaterials. And we can see that in Suzano, for instance, we have increased our investment in research and development in biomaterials and biorefinery from 10% of the total investment 10 years ago to actual 40% nowadays. That's how much we believe in biomaterials and how these biorefinery currents that we can take from our process can change the world and the products as we see today. Suzano actually has this purpose, inspired by trees, renewing life inspired by trees. And that leads to generating new materials, renewable sourced, in several new markets that we can actually reach. This transition, as you said, Ludo, is being taken in several different directions at the same time. It's not an or equation, it's like an together. It's like pulp, paper, plus other materials you can bring to the market. And in Suzano, we call this innovability. For us, innovation has to be attached to sustainability. That's how we want to do this. And we also believe in collaboration. And I think this was a topic mentioned the entire morning, how much collaboration can accelerate the results and time to market of biomaterials and solutions in bioeconomy. And as an example, Mr. Jan Poranen will talk about the partnership we have with Spinnova. Spinnova is a partnership that started in 2017, and what we saw is a disruptive, innovative, sustainable solution for the textile market. We saw on the previous presentation that the textile market has very little participation of natural fibers. We are really based on fossil-based fibers today. And what Spinnova did is present an alternative for that. And we jumped into the opportunity of having our craft fibers joining this opportunity. Collaboration is key to get biomaterials out there. And to address the last part of the question regarding performance, Ludo, my personal perspective of it is that any new material will have to go through a learning curve. It's very unlikely that we can tune a material that will check all the boxes that are required in performance, in economics, in scalability. There is a process to get there, but we have to understand the value propositions of these, the biomaterials that are coming to the market. They may not check all these boxes, but they have a very good compromise in terms of sustainability and what they deliver in terms of carbon footprint, renewable carbon, recyclability, maybe even biodegradability to these new value chains. And we are betting on this. Suzano is betting on this, putting a long-term goal of offering 10 million tons of renewable materials by 2030. And of course, we are not talking about pulp. We're not talking about celluloses. We're talking about celluloses plus a bunch of new materials like the lignin, like the nanocelluloses. We are working with Spinnova and other segments, with biocomposites and other ideas that we have on our portfolio. I think that's it.
Thank you so much, Viviana, for this nice introduction, and you already made the link to Spinnova. We will come on that later. I would like to continue with the second process industry, and this is Braskem. And we have, so we stay in Brazil for a while, and from Braskem we have among us Roberto Werneck, who is chemical engineer with a Master in Science degree from the Federal University of Rio de Janeiro. He has worked in many industries, so as the chemical, petrochemical, oil and gas, and also mining and metals. He teaches process control at the Catholic University in Rio de Janeiro. And after 7 years leading the process technologies for renewables in Braskem, the team that develops new processes and supports the green ethylene plant in Brazil, Roberto is now in the innovation and technology area in Braskem, focusing on open innovation with responsibilities in technology intelligence, scouting, and facilitating external collaborations with academia and R&D institutions. If you listen to that, it's very clear that Roberto is perfectly placed to answer questions on the new things that we can expect, etc. Roberto, Braskem started really as a, if I can say so, classical chemical company, and is now strongly engaged in making the same polymers as before, but bio-based. You are the biggest producer of biopolyethylene. What makes it so important, and what is also your driver to do this? And do you also expect that in some cases bio-based materials will be better performing? It's difficult for the biopolyethylene, of course, or safer compared to petro-based? And if you, or do you think that only you will stick to drop-ins? Up to now, you make biopolyethylene, or do you see other opportunities?
Okay, so thank you, Ludo. It's a pleasure to be here taking part in this panel. So you're right, Braskem started from a merger of many different chemical companies based on petroleum products. But back in 2020, Braskem decided to make a big bet that was aligned with our sustainability goals at the time. We decided to start 200,000 tons per year biopolymer plant. So we decided to start big. So, and this decision made us overnight the largest player in the field of bioplastics. And we still are very relevant in that space. So at the time, bioplastics were a niche application mostly. And then all of a sudden, we had a big plant producing a lot of material. So our driver 11 years ago was already sustainability. We recognized the need for lower carbon footprint. We saw that demand from our clients. And so we positioned biopolyethylene as a strategic enabler. And it really happened. Our clients came up with amazing solutions. And those helped make BioPE a case study. Sometimes when I meet people and tell them I'm from Braskem, sometimes they know a lot about BioPE and they are get very soon to the market, and that meant taking advantage of the infrastructure that was already there. So providing a drop-in product was really important for us to achieve a relevance in a short time. And I would say that drop-in is still relevant in some situations. For instance, when we talk about circular economy, when we talk about recycling, along the value chain, we have people working in sorting, in mechanical recycling, and so on. And these people have facilities that are working right now. So anything that you can put in that is a drop into those facilities will be easily applicable, right? So that said, drop-ins shouldn't be a limitation because we need new materials with improved properties. So we need to be open to innovative processes and technologies. We need to improve safety, sustainability, or even the performance of the materials. And I completely agree with what Bibiana just said about collaboration and partnerships. We need to work with others and bring in new ideas to be able to provide new solutions, new materials. And I would like to just stress one other thing that's important. Apart from our role in providing the materials and using the technology, we also need to help communicate the value. And this panel is a great opportunity that we need to communicate that there's a lot to do and we need to focus on measures that have scientific justification that are really going to have an impact and try to avoid easy measures that get a lot of repercussion, but that are not really what's going to solve the problem in the long term.
Thanks a lot, Roberto. So it's really clear that the bet on making use of this existing infrastructure could make the step a little bit more easy. And then indeed, and you already touched a very important point, is recycling, so that we can bring in in the recycling system, in line with what was just presented by Michael Karius, this recycling of bio-based materials without the need of extra systems in the recycling system, etc. So this was first introduction by two process industries. So these are industries that transform the feedstock, the raw biomass into materials. And now we will move to users via the manufacturing that are really making the products. And Jana was already introduced by Bibiana, so we will start with him. So Jana Poran is the CEO and the co-founder of the sustainable textile material company Spinnova. Spinnova is on a mission to transform the way textiles are manufactured globally. The Finland-based Spinnova has developed a breakthrough technology for making textile fiber out of wood or waste. So, but they can also make leather kind of things, textile or food, some from leather waste, textile or food waste without harmful chemicals. Yeah, it's really interesting to see that. And Jana, you are working together with Suzano. I think this collaboration was already mentioned, and I really hope that you can say a few words how this is going on and so on. So you're developing these natural biotextiles. Can you really explain how the collaboration started and what inspired your company to do so and to go together from Finland in the middle of the forest to Brazil in the middle of other forests, if I can say?
Hey, thank you very much. Very great pleasure to join this forum, and good morning, good afternoon, good evening. Why I chose my background, I don't know if it is like a green revolution what is coming, but it is actually the Aurora Borealis, because I'm locating at the moment in the North Pole in Finland. But maybe a couple of words about the Spinnova, that who we are and what we do. So we are, let's say, still quite a small company. Currently we have about 50, 60 people in the company. We started in 2015. The innovation is actually coming from the nature. So it was the year 2009 when my co-founder, Mr. Juha Salmela, was attending to the conference in Oxford University. And there was an interesting talk about that, how the spider is spinning the silk. And because we are coming from the pulp and paper sector, and on that time we were focusing and doing research about the nanocellulose and the microfibrillated cellulosics, then Juha got the idea that what if we could be able to spin those natural fibers a little bit in the same way as the spider is spinning the silk. And then the innovation started. So now we have been working about 6-7 years as a company. Now we are moving into the first commercial scale up together with Suzano, and really making this like a global scale and a big opportunity for the future. But why we have been so happy to work with Suzano? I think it is very simple reason. Since we are using natural-based raw material, that is what we need. And when we started to discuss with Suzano, then it was almost immediately sure that now we have a partner available who has the same vision and the same strategy as what we have. They were looking something like a breakthrough, that how they are able to use microfibrillated cellulosics in a volume applications. And what we have started at the very beginning, the only goal is that our technology, our production process is going to be volumes in a near future. And then because the vision and the strategy was totally aligned, it was very easy to decide that, okay, let's go for it. Because as you know, Suzano is producing, let's say, enough fibers by today for our purposes. If you use all that, I think it is about 11 million tons annually what they are producing as a paper pulp. But if we are using that for the textile fiber production, it is enough to replace about 40% of the global cotton production. So I would say that even that we have a lot of discussion that, okay, if people are starting to use wood in a big scale, that we are lacking of the trees or the wood. But I would say that when you compare, for example, to the cotton volumes, and then only one company, Suzano, is able to produce that much, I would say that the raw material is not going to be the issue in the short term. So we also that we discussed earlier, and I heard about the collaboration. Of course, the one like a big thing what we have learned now working with Suzano like 4 years. Now this is really going into the action, because there has been a lot of talk inside the, for example, the pulp and paper sector about the bioeconomy, about the new bio-based products, but now we are putting that together. And the collaboration is the key. So you might even think about that, why the Finnish-based company is collaborating with the Brazilian-based companies. But for us, it doesn't matter. Because if you have the same vision, same goals, and you have a great people to work with, so why not? And it has been a great pleasure for us to work with Suzano.
Thanks a lot, Jana, for this nice contribution, and you really showed that you started to look to spider systems, etc. So you were looking a little bit to the how to mimic the nature, and so this brings us back to the lot of discussions that we had already these days about people living in the Amazon that know very well what plants and animals are doing, etc. So in that way, it really makes sense to look at it. And it's also nice to see that manufacturing is combined with this production at large quantities of these celluloses and microfiber-related cellulose. I certainly come back on the recycling later on in the discussion. A little bit also this morning, we had a short video showing a person living in the Amazon and making toys of the Meriti palm tree. And so this brings us completely to the big company, really brand owner, Lego. And if I'm not mistaken, Lego started early last century also with wooden toys that were then transformed into the famous bricks that we know all from Lego. And so it's my pleasure to introduce you Nelleke van der Pijl, who is Vice President of Materials at the Lego Group. Since the start of her career in industry in '97, Nelleke has worked in research and development organizations in the chemical industry and the consumer goods industry. She joined the Lego Group in 2014, and in her current role, she is responsible for the current and future materials in Lego core line products. So this is really very important to see how people are thinking for the future. Her area is scouting technologies and performing materials research and development in partnerships with supply chain partners. Nelleke has a PhD in chemical engineering from the Delft University of Technology in the Netherlands. Nelleke, I really have a similar question to you compared to the one to Jana. You work now with Braskem, but that's only one of the issues, I think, on the use of biopolyethylene. Lego is already a kind of sustainable product. I mean, nobody throws away Lego. We use it from generation to generation, and still your company seems to be driven by doing better. Can you explain, and can you give us also a little bit of glimpses of what your company is looking forward for the future?
Thank you, Ludo, for the very nice introduction. And great to be here. Nice to be talking to such a broad audience. yeah, of course, you are mentioning this reuse of our product. And this is, of course, one of the starting points. If we look at the Lego bricks, we are encouraging consumers to reuse their bricks. And if they don't have use anymore for the bricks, then we encourage them to hand them to us. And we do that in the US and Canada at the moment in a program which is called Replay. And through that, we allow consumers to hand them back to us. And then we hand them to children in need. So the bricks will have another life in the hands of children. So that is one aspect. We are looking at the durability of our bricks as a very important aspect that we are also looking for in new materials. So that's one thing. The other thing is that we're looking at the beginning of life of our products, and we want to, as a company, have a minimum impact on the planet. So the sourcing of our materials is also very important. And that's why we look at the use of bio-based materials. And we're also looking at other opportunities to source materials such as the CO2 capture, which I think in many cases is still in the early stages. And we see now some opportunities maturing there, and the use of recycled materials. And that is the reason why we've worked with BioPE. We believe that the biopolyethylene is a wonderful material, and we are using it in our products. We've been using that since 2019, I think, or 2018. And we're expanding the use of BioPE in our products. In general, bioplastics are of interest, but there is also this aspect of durability. So that is definitely something that we need to study, so that we can still guarantee that the products will be in use for the longest of time possible. We're also thinking about what to do end of life. So that is something that we're now more focusing on. To create a pathway to come back to a starting point for new materials is also something which is in scope for us. And with that, I think I sort of answered your question. I don't know if you have any more explanations you would like to hear, Ludo.
I have more questions, but we will come later.
Yes.
To that.
Okay.
Thanks a lot, Nelleke. Finally, I would like to present you Dr. Kitsiltas, and his research is focused on sustainability and emerging materials such as nanomaterials, polymeric and soft materials, biomaterials, glassy and amorphous materials, self-healing materials, bio-inspired, etc. During his 7 years with the company, Helper has led research projects in a variety of polymer-based applications, including advanced and sustainable composites, polyurethane foams, and his technical work on developing sustainable and advanced materials is going in the direction of graphene nanoplatelets, reinforced polyurethane foams, cellulose-based hybrid composites, 100% PCR from carpet recycled process-based polypropylene, and rice husks filled polypropylene, etc. And also biocarbon from coffee chaff led to implementation on NVH foams, console substrates, carbon canisters, etc. So really a huge amount of different things that you are doing, Helper, and you are looking in which way, for instance, your company, Ford Vehicles, could make use of these different bio-based materials, but also if I introduced the word performance in the beginning of this panel, I think this is really also something that you are looking strongly to it. I think that the car industry is not always seen as the big, if I can say so, a little bit frank, a favorite for sustainability, but all of a sudden we saw a steep increase, for instance, in electric cars, especially also in Europe. And of course, this is not the topic of today, but we see that also the car industry is moving a lot to these composite materials with a lot of bio-based content and with also improvements concerning lightweight, etc., where biomass could offer some opportunities. So allow me to move to, okay, so what can you present to us, what is possible in this world, and how is the car industry looking forward to this bio-based economy and bio-based materials?
Ludo, thank you so much. I will tell you, you are the one of the best moderator I have ever seen. So this is awesome. Thank you so much. And also, I would like to thank our panelists because they made our life easier, and they already talked about a certain part of the circular economy and sustainability. So that makes my life easier. And I would like to say good morning and good afternoon and good evening, everyone. I would like to be there in a beautiful country and see that, you know, the people face to face. I'm hoping that next one we will hopefully have the face-to-face meeting together. So let me just give overview, and we will start with the sustainability. It is in our DNA. If you go back to 100 years earlier, and you see that our founder, Henry Ford, he experimented so many new materials. And today we just say, okay, we discover new materials. We are going to use industry first agricultural waste or bio-based material. And I look at Henry Ford's experimental book, and he already looked at this material 100 years ago. Look at that vision. He just dreamed 100 years later with that certain environment. So that time, the technology is not advanced, the lack of information, and he just visioned 100 years ago. So we are just pretty much following his footsteps to make sure our car is green. So if you look at the automotive industry, I think, Ludo, you are absolutely right. Sustainability wasn't a big deal maybe 50 years ago, but now we are seeing the huge interest. Every companies, they publish their sustainability reports. Every companies, they have target for sustainable materials. But I just want to be, the favor for my company. We are the leader in terms of pushing for sustainable material for automotive application. I'm not mean, and we also demonstrate as well. So give you a couple examples, and if you look at the current environment and at the Ford Motor Company, and our goal is 2025. At least 20% of our vehicle is going to be sustainable products from the plastic content. If you look at our mid-size SUV, and we have around 700 pounds of the plastic material. So we are really pushing around 300 kilogram plastic material for each vehicle. And if you look at how many parts we have in the vehicle, we have 40,000 parts, and 12,000 of them is the plastic-based material. And we have a really ambitious goal. Make it this 12,000 part in someday using only sustainable, means recycled and renewable based material in our production. So this is a really ambitious goal, and I think we have a really good roadmap and really good plan to get, the hopefully one day is 100% using sustainable materials. This can be used in the injection molded materials. We already talked about the textile material. It seems there is a change from the leather, because leather is always sign of the luxury, but now with the consumer, they really want different materials. Can we replace leather with alternative materials? Can we use cellulose-based products, or can we use other sustainable options in terms of using polyurethane-based, but getting the polyurethane from the bio-based source? That's a huge interest. So the journey is, the intent and the journey is not easy, am I right? Because sustainable products, they always bring all their challenge as well. We need global effort. We cannot solve these sustainable issues by ourselves, and people already stress we need the global effort. So what we are doing actually, that we give already a couple examples, and we made the largest sustainable parts, injection molded parts in today's vehicle for interior application. Most of the times people, they told us, oh, natural fibers or sustainable materials is not gonna work. There is a smell, like other issues, and material is not going to meet the properties, and you guys are going to fail. And we show over and over, this is not true. We just need to work, and we need to address the challenges, and we have always overcome these challenges. So we made it the largest sustainable injection molded parts using cellulose materials, and actually we did really good because right now is the global glass fiber shortage. So can we get the benefit, from the cellulose or trees, replace certain part of the glass fibers, or maybe complete the glass fibers with the cellulose fiber in the formulation? And sometimes people, they get to say challenge, okay, you can use certain sustainable materials, either bio or recycled material for interior application, but its exterior is a challenge. and we demonstrate that we made an industry first headlamp housing from the coffee chaff. Just think about coffee chaff is like people they consume a lot, and most of the times it stay in the landfill. I think as Yana's country, they spend like every year per person 26 pounds. In the US, every person consumes around 10 pounds of the coffee. Just think about how much waste we generate from that one industry. So the point here, you can make it, the exterior part, and also this is the safety critical part, and using sustainable products. We used to have 40% talc is a mine process, and we use bio-based material to replace. We got weight safe, we got cost safe, and we got the sustainable content. It's all run. So my point is, people, they will tell us this is not possible, but we need to be resistant and we need to be patient. I think it's the biomaterial will be the solution, and it may take a little time, but we have to really stick with them, and we have to really persistent to implement. The other things is, let's talk about a little bit the recycling, because the recycling is getting really big deal, and there is a terms, you can use the mechanical recycling, chemical recycling, and also, there is interesting technology is the carbon capture technology. And I think is our favorite at this point is more mechanical recycling, because it has better LCA, life cycle assessment, and it gives us really good benefit in terms of the cost and also in terms of the life cycle assessment. Still, we need to advance, because we need advanced mechanical recycling. Sometimes our source is a mix of the plastic. How are we going to make it separation? How are we going to make this material meet our interior and exterior requirements? Interior materials shouldn't have any odor and smell issues. In the exterior, we need to make sure consistency and no issues on the visible surfaces. So this is really important. Chemical recycling is really major, but it is not interest at this point, because we just want to make sure we are doing the right things for the environment, and we will put more effort on the mechanical recycling side. But I think as the Nelike and others also talk about the carbon capture technology, and we truly believe carbon capture technology is coming very soon, and we are really experimenting in the polyurethane, PET, and the polycarbonate side, how we can capture the CO2 using certain catalyzed technology and convert the monomer and to make a certain part of the vehicles. So we mostly use polypropylene, but in our vehicles, and the polypropylene and TPO formulation, up to 40% of the plastic we are currently using, but we are also using polyurethane foams, we are using PET, polycarbonate, ABS type of polymers. Can we use recycled, sustainable options, either recycle or bio-based source for this plastic material? And it seems we need to work together, and we truly believe this kind of platform, we are going to share this information and our desire with the people, and people, they always come with unique ideas. I'm pretty sure we will find really good collaboration after this panel, and people, they reach out to us, they said, we have really good materials, is there any way you can use it? And also, I would like to remind one thing, I come from the farmer family. I have 4 brothers, 2 sisters, and I always want to be help to agricultural industry, and it's coming from my DNA, but farmers, they always need to work hard, and they always need to work many years to get to full retirement. Can we use their waste material? Because I don't want to sit there burning their waste material. Can we use this waste material using upcycling methods to make a valuable part, either car or Lego or some other applications? Thank you so much for this opportunity, and I'm looking forward to discussion as well. Thanks.
Thanks a lot, Albert. You mentioned already this coffee chaff, and if you put it in the landfill, the coffee chaff will start to emit a lot of greenhouse gases. We never count this, and so this is also a point that we have to consider. If we take plastics at the end of life, depending on the country, in a lot of cases we just incinerate it, which again releases CO2. If it was bio-based, it brings it in a circular system, so we are not really adding something into the atmosphere, but we are not contributing to any sink of the carbon neither. So if we can reuse it in a certain way, it really makes sense. And in that way, I would like to move then back to Roberto. How is your company looking to this? Alper was already mentioning mechanical recycling, but I can imagine that a company like Braskem is also looking to chemical recycling, really, in order to be able to move forward and to make whatever you want out of it in a second round, if you want. even also when it is bio-based?
Yeah, Ludo, recycling is really, say, a key component of a circular economy strategy. And I guess one of the main challenges right now is to transform the linear economy that we have, which is basically petroleum to waste and all the economy in between, to something where we can reuse waste and by doing that, reduce the requirement for petroleum-based materials. And so we are involved in many activities for both mechanical and chemical recycling. They are at different maturities right now, so low-hanging fruits are normally related to mechanical recycling, but we see that we need to do more, and there are very interesting technologies out there that could be used to produce renewable naphtha, for instance, or even to recycle polymers into monomers, and that would allow us to produce materials with better properties in larger quantities as well. But I would say that regardless of the source of carbon, one important thing is that we can always recycle plastics. So by adding bio-based feedstock, recycled feedstocks, and even CO2 products, so materials where the carbon comes from CO2 capture, we're basically replacing the input of petroleum materials, so the carbon positive fossil material. So this is the way to get there. There are other solutions, and you already mentioned lightweighting. So lightweighting is also a way to avoid the demand for more raw materials. And I guess Michael's presentation gave a very interesting look at the future. What happens when we really reach a circular economy where we don't have fossil anymore and we have a participation of bio-based, recycled, and CO2 materials. But there will be a transition period, and what I see right now is that the transition period will include an interplay of very different technologies, very different materials. We'll have to use the existing technologies for very quick action, so we start reducing CO2 emissions right now. But at the same time, we have to invest extensively in R&D to be able to reach new solutions, better materials, and this is where I guess chemical recycling will find a very nice place.
Thanks, Roberto. I think the paper industry is a perfect industry of recycling, and 90% of the new paper that can be made is made of old paper, etc. So in that way, I would like to ask Bibiana in which way they can transform this recycling technology of paper towards the new products that you are making. Is it immediately taken into account? You're also making a lot now of resins and adhesives for wood panels, etc. Is this also taking into account that recycling there is a possibility on the long term?
Well,
are you still? Yeah, go on.
Okay.
Please go on.
I think that recycling, the new products and recycling is like a concept that they're being born together now. We don't work anymore in developing a product without already thinking on how it's going to be recycled and if it's going to be biodegradable, if it's reusable, and thinking about the value chains that they're going to be inserted on and how they're going to interact with these new matrices, that they're going to play this role in these new matrices. I think the difference is that now this is coming from the beginning. right? We're in a new time and raise of awareness of the consumer of the need of bioproducts, bio-based materials that are recyclable, that are reusable, and this awareness is making us work differently from the beginning. You brought the paper as a great example, and it really is. But paper still has challenge to be recycled, right? Think about the flexible paper in packaging. They have plastics, they have barriers containing fluorine that are also being very much discussed if should be continued to use. So paper is also a challenge today. And this is a big discussion because the recyclable process, the recyclable entire chain goes from the collection, actually starting from the correct separation, and then the collection to actually be able to use these materials again. And it's a challenge of today. It's not a challenge for the biomaterials of the future. And once we start thinking about the problems we have today, the solutions for these biomaterials of the future are going to come in the same direction. What we are trying to do in our research for our biomaterials is thinking about it from the beginning. And once again, I will bring partnership to the table, collaboration to the table, because mostly Suzano is a raw material producer. Lignin or MFC, in the case of the partnership we have with Spinova, MFC is going to be used in textiles. How is the textile recycling chain works? What's the end of life, as it was already brought here? How is the end of life of textiles? This is not our common knowledge. This is not Suzano's competence. So we have to partnership with the correct people to give the correct solutions for these biomaterials. And that's how we're trying to build this new portfolio of materials, thinking in a broader way on how we are going to work with all these challenges ahead of us.
Thanks. Before I will move to textile, I would first try to move to Nelleke, to Lego again. I think we discussed about the bricks, but you also have a lot of packaging. Yeah, you have the boxes, and then all the bricks are in separate bags, etc. So how do you think about that, taking into account also what Viviana was saying about recycling of plastics, but certainly also of paper, etc. What is the idea of a brand owner like Lego on this? Can there be improvements still, or are there still improvements possible in the packaging of your products?
Yes, it's a very interesting question. Of course, a lot of people think about the bricks only when they talk about Lego products, but obviously there is more to it. So packaging materials are definitely also in scope if we want to reduce our impact. And we have made our first steps and also an announcement that we will move away from the use of plastic in our pre-packs. So I don't know if you remember opening a Lego box. The cardboard box obviously is FSC certified cardboard. Then if you open it, you see a lot of plastic bags, transparent polypropylene bags. And we've assessed what would be the opportunity here. And we came to the conclusion that we want to convert to paper bags. So we're now doing a conversion from plastic to paper, which then allows the consumer to recycle within the current infrastructure. And so recycling is very much in scope there. But I would also like to comment on the opportunity that we see in recycling of plastics as a way to source materials. So we already some people mentioned here today the mechanical recycling, and you may be aware that very recently we've introduced a recycled PET brick, So that is a prototype still, but we are working towards scaling that, and we're very serious about this. So we developed this together with a compounder. And of course, the sourcing of the PET is very important there. So we're now using recycled PET from mechanical recycling, which is of very high quality, obviously, because it's food grade material. But we also believe that chemical recycling will be a good source for PET of the future. So we're very interested in assessing these technologies and getting access to these types of technologies, or at least as our supply chain would get access to this, our future supply chain. And in addition to that, we're also involved in the development of bio-based PET. So we are looking at it from the full circle, all the alternatives that are there, we are tapping into.
And then
you're
looking only to bio-based PET or also to bio-based PEF, for instance?
Well, if you would look on the internet, you would find that we're also investigating bio-based, so PEF, so alternatives to PET. That is, of course, a very early stage technology. So, of course, the PET, the mechanically recycled PET, is something that we can tap into already at scale. That is just a part of our journey. And as mentioned by Nina, Bibiana, I mean, we are very much depending on partners. It's not something that we do on our own. So the compounder and also the supplier to the compounder is super important in this. And those suppliers can be many, right? Because it is PET, we can also think about the end of life. So the end of life is also thought into this. So we're investigating, can we actually recycle this compound that we've created? And also, can we source from recycled sources or from bio-based sources? So we think the whole cycle into these solutions. And that's also why we like PE, because there is an existing infrastructure around PE. And we expect also that in the future, there will be a bigger infrastructure to recycle PE and as a source to us. So it's not only bio, but it will also be recycled plastic that we can use in our products in the future.
In order to allow also the audience to ask a few questions, I will quickly jump still to Diana. I think in Europe there's a lot of discussion ongoing and also a lot of research projects on textile recycling. But textile, it's a mess. In fact, it's a lot of different chemicals. There are also different materials in it used, etc. Do you think that your fibers can have a positive contribution to this recycling improvement for the future?
Ludo, we have 3 more minutes, please, okay?
And do you have questions from the audience? Then,
yes, I have one question.
I have one question. Quickly, and then we can do that. Yeah. Jana, can you give a short answer?
Yeah, very quickly. I think it is good to, let's say, that how we are producing our fiber. So the method is very simple. You can use multiple different raw materials like a wood pulp, what we are doing with Susanno, leather waste or the leather, what we are doing with Eco, agricultural waste like wheat, straw, or barley, or even the textile waste. And then what we do when we take the raw material into the process, we are just mechanically refining all the fibers into the micrometer level. And then we have water, and then our innovation is that how you are able to, a little bit like a spinning like a spider, to spin those microfibers and water. And then we are just drying the water away. So we are not creating any waste. And then we have a fiber, what you can use as a cotton or wool or linen, for example. But what is the good thing is that we can take this fabric back to our refining process and refine that again and again into the microfibrillated cellulose. And that is totally different, for example, the paper recycling, because in the paper recycling, you normally, the quality is going down because you are breaking the fibers. But now in our case, actually the refining is easier when you do that again and again, and the suspension what you are creating is more homogeneous. So the quality is even going a little bit up. So, and that is done totally mechanically, because we are not using any harmful chemicals, we are not dissolving anything. And then, as Bibiana said, we have been thinking that this is the future, that when we have a big volumes available spin-off fiber, we can take that back and use as a raw material. And that is something for the future.
This is great to nearly finalize this panel discussion. Teresa, other questions from the audience?
Yes, Ludo, there's one question that I will take the liberty to modify, because I don't think the question was how the small rural producer can participate in the capturing of CO2. And I think it's not appropriate to this panel, but I think would be interesting to have just a very short view on how can small and medium-sized enterprises participate in this renouveau, I don't know how you in this renewal, in this new, okay?
Maybe who wants to start on that question?
Very shortly.
Please don't wait too long, because we do not have much time. So who?
Commonize, or just to talk about the carbon capture?
I think in general.
Okay, I think it's the, I just want to give you an example. So we deliver the coffee shop with a small compounder, and the company does size. We never look at, who is working in your company. It is really important for your idea and how this idea is gonna help us to make sure we will invite the next generation materials. And we are willing to help, and one of our goals as a company, work with the startup and small companies to make sure their dream comes true.
Thanks a lot. Maybe one of the Brazilian friends, Bibiana or Roberto, can add something to it. Just,
okay.
Is there something that Bibiana or Roberto want to say or to add to it?
I can only agree with Alper and say that there's enough room for collaboration at all levels. And we need ideas, we need fresh ideas, and we need to cover all the range. So it doesn't make sense for us to concentrate on the large scale production if we don't look at what's going on around us. So yes, there will be a role for creative, innovative, small companies.
With these words, I would like to thank the panel and the audience for listening and for the very nice discussion. I think, Teresa, we could still go on for a very long time. I would like to wrap up a little bit by saying that a circular approach of chemicals and materials made from wood or biomass carbon will keep carbon in a kind of sink system via the materials in our daily use. So this is really an opportunity for us. This bio-based carbon stock will allow a slow replacement. It was really mentioned today in the discussion of fossil carbon into biocarbon-based materials, and it will create highly performing materials. We had no time to discuss toxicity removal from the old materials, and in that way it will create health and good life, quality impact, and high societal acceptance, and this is really in line with what we heard about the restoration of Amazonian forests, etc. So really, I thank you all for the very nice discussion. It's not finished, we can continue later on. And I give the floor again to Teresa.
Thank you, Ludo, thank you very much. I think this was a very enriching panel, making the bioeconomy more concrete and tangible. Cars, textiles, wood panels, microfibrils, toys, you name it. It's really stunning. So thank you very, very much to all of you. Thanks for being here, Bibiana. And I would ask you to join me to applaud this panel. Okay, thank you very much. Now, before we break for lunch, I have an announcement. Antes de se irem embora para almoçar, de desfrutar das delícias paraenses, queria anunciar que esta noite no Teatro da Paz, aqui em Belém, teremos um espetáculo com a Amazônia Jazz Band às 20 horas. Todos os participantes do fórum são convidados.
We shall have a show this afternoon at 8 p.m. All participants who are present here are invited. It's enough to show your credentials at the entrance of the theater, and you will obtain your tickets.
So tonight at 8 p.m. there will be a concert at the Teatro da Paz here in Belém with the Amazonia Jazz Band. To all the participants of the forum, you're all invited to the event free of charge. Just bring your credentials, your badge, into the theater ticket office, ticket booth, and you will get your ticket. This is a courtesy of Ursula Vidal, who is the Secretary of Culture of the state of Pará. And now I'll release you for lunch, but beware of this delicious paraense gastronomy. We need you back in 60 minutes. Portanto, agora podem ir almoçar. Cuidado com as delícias do Pará e de volta, por favor, daqui a 1 hora, 60 minutos. Bom apetite!